Hey guys, welcome back to Crick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Antipodal points. This is an easy problem. However, I feel like this is a bit of a tough problem. You guys can go over it now. So there's not a lot to explain in this problem really, but just imagine that the Earth's surface is a sphere and the temperature is a continuously varying function. As in, while plotting it, there won't be any breaks, and by breaks I mean like something like this, right? Won't be won't be like this. It will be like this graph. So yeah. So a few hints I'd like to give you guys is, first of all, this will require a bit of calculus. Calculus that you usually learn in your 11th and 12th grade, right? Other than that, you don't really need the entire sphere to find out two antipodal points. So basically, there are like infinite number of such pairs on a sphere. That is because for each cross section, for each circle cross section that you take out of the sphere, you will find two antipodal points, at least two antipodal points. So just try to focus on like one circle going from 0 degrees all the way to 360 degrees. And yeah, so think about this. And another thing is, I think it's better to try to plot these on a graph, like try to plot the temperature versus theta or something. Theta is basically the degrees, and T is basically a function of temperature versus time versus theta or versus degrees, basically. So the neat trick actually is that we've been given that the temperature is a continuously varying function, right? But eventually we've been asked about the difference in temperature, right? Not the difference. Actually, it's saying that two opposite points on the Earth's surface have the same temperature, but that basically means that the difference of temperature is zero. So let's just define a function called t of theta, which is actually t of theta minus t of theta plus pi, which pi basically means 180 degrees. So that's the completely opposite point on any cross section, right? And this angle is basically theta. So now what happens is, since these two functions are obviously continuous, this also becomes continuous. And we can apply some of the properties that we learned during calculus on continuous functions to help and come to a conclusion about the difference between temperatures of opposite points. So coming back to any simple continuous variable function, first of all, you guys must remember a theorem called the mean value theorem. That basically said that, so for example, at a, this is my function, this is a function f of x, and this is x. So x equals to a, x equals to b. Let's say this is the value of f of a, and this is the value of f of b. Right. And the function goes something like this. So if I were to say that, could you find me a point between a and b for which the value of the function at that point, let's say that point is y, or just have it as x1. So if could you find me a value x1 such that f of x1 is equal to f of a plus f of b, so divided by 2? And the answer is yes. You'll always find such an x1 given the f of x function is continuous, right? This is what the mean value theorem basically states. So using that, I could also say that if f of a will be equal to, let's say, any positive value, let's say plus 10, and f of b be equal to minus 10, then I could say that there lies a point xi between a and b for which f of xi is equal to 0. And I mean, 10 isn't like any special value. We could have anything. So basically, just to denote a constant value, we'll just call it c, plus c and minus c, right? So now coming back to our t function, this function over here, can I say that for any cross section, right, t of 0 would basically mean, well, this t actually was the initial t. So let's just call this t prime, right? And going to the initial t, so that would be initial t of 0 minus normal temperature of pi, right? And what would be t prime of pi? T prime of pi would be t of pi minus t of 2 pi. Now, since 2 pi and 0 are basically the same thing, I could call this as this, right? So you can see that t prime of 0 is basically the same as t prime of pi, and sorry, the negative this. So I mean, this called t prime of 0 equal to positive c, then t prime of pi becomes negative c. And I guess you guys can already start to see that t prime of some theta I in between 0 and pi would give us the value 0. And what does this mean? This means that for a particular theta between 0 and pi, we have a case where t of theta minus t of theta plus pi is 0, which basically means that these two are equal. So we haven't found that theta, but we've proved that there is a theta in between 0 and pi for which this case satisfies, right? And so theta is where the first point is, and theta plus pi is where its opposite point is. So, and we just proved that using just the fact that this function was continuous, we eventually led to the fact that the difference between temperatures of 2 points would be the exact same. And since we did this for just for one cross section, we could like try to imagine cutting the earth with a knife. We could just now rotate our knife at a degree around the z-axis and make new cross sections. And for each of these new cross sections, we could get at least one more point. So that basically means that we'll have infinite pairs of these kind of points. So I hope you guys understand what this is. This does take a bit of calculus, with all that mean value theorem and whatnot. But yeah, thank you for watching.